Hello guys, welcome again to mathematics learning video with me, Miss Diana. Okay, in this video we're gonna cover a topic, namely probability. In this probability topic, actually we're gonna cover some subtopics, which are sample space, probability, Venn diagram, and then tree diagram, and then conditional probability, and etc. Particularly in this video we're gonna cover about sample space. What is it, sample space? Actually, this sample space is the pre-requirement subtopics before we get into the probability. Why? Because it will be used in calculating the probability of the event. Maybe you are familiar with this symbol P of A. What is P of A? It is the symbol of probability of event A. So how to calculate the probability of event A? It is simply the division of the number of favorable outcome. In this case, the number of favorable outcome is the number of outcome that leads to event A occurring. So we can actually make it short like this, N of A. It is like the short writing of the favorable outcome, and then we divide it by the number of total possible outcomes. We can make short it by writing in N of S like this. So actually the number of total possible outcome, it is what we call a sample space. So before we calculate this probability of event A, we actually have to understand how to calculate or determine the number of total possible outcome. Okay, we're gonna talk the sample space of coins, and then about dice, one dice, two dice, and etc. First thing first, let's talk about the sample space of coin. In the first case, we're gonna talk about a one fair coin. Okay, whenever I say about fair coin, it means the coin has the same chance of landing on either side, or the weight of coin is the same in either side. So let's say I toss or I flip a fair coin in the air. How many possible outcomes that we will have? Because a coin has only two sides, which is the head and tail, of course the sample space of a coin is only two, which are head or tail. Okay, so the N of S, the number of sample space, we can write it in here is 2. Okay, now let's move to another case. How if we have two fair coins? When we throw two fair coins in the air, how many total possible outcomes that we will get? To solve this, we're gonna use tree diagram to solve this problem. So I'm gonna put all possible outcome of the first coin in here, and then I'm gonna put all possible outcome of the second coin in here. When we toss two fair coins, actually in the first coin we also have two possibilities. In the first coin, all the possibilities that we will get is head and tail. Okay, let's say in the first coin we get a head. Then for the second coin, actually we have another two possibilities, which are head and tail as well. So we can make two branches here. If we have head in the first coin, on the second coins we will also have two more possibilities, which is head and tail. Likewise, if we have a tail in the first coin, actually for the second coin we can also have another more two possibilities, which are head and tail. So we can have another two branches here. As you can see here that we can have four possible outcomes whenever we toss two fair coins in the air, which are head head, head head, and then head tail, and then tail head, and then tail tail. So in here, whenever we toss two fair coins, actually we can have four possible outcomes. So N of S is 4, which are head head, head tail, tail head, and also tail tail. That is for two fair coins. Now how if we have three fair coins? To find all the possible outcomes of these three fair coins, actually we're gonna also use this tree diagram. Okay, this is for this first coin, this is for the second coin, and this is for the third coin. Okay, for the first coin, of course we have two possible outcomes, which is head or tail. Okay, let's say that in the first coin we have a head. Then for the second coin, of course, we also have another two possibilities, which is head or tail. Okay, we can make a branches here. And whenever we have head in the first coin and then head in the second coin, of course, in the third coin, we also have two more possibilities here, which is head and tail. So we can have another more branches here, like this. And if we have a head in the first coin, tail in the second coin, of course, in the third coin, we also will have two possible outcomes, which is head and tail. And we will repeat the process likewise we have here to the first coin whenever we have the tail. And notice here that we have 8 possible outcomes of 3 pair coins that are tossed in the air, which are head, 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 and then head, 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 tail, and then head, tail, head, and then head, tail, tail, and then tail, head, head, tail, head, tail, and then tail, tail, head, and the last one is tail, tail, tail. So we can write n of s of 3 pair coin is 8. Now in here we have 2, in here we have 4, and in here we have 8. This is for 1 coin, this is for 2 coin, this is for 3 coin. Do you see any relation between the number of coin and the number of n of s? Actually, in here we can see that 2 is 2 to the power of 1, and then 4 is 2 to the power of 2, and then 8 is 2 to the power of 3. So it depends on how many coins we have. If we have like 5 coins, then the n of s will be 2 to the power of 5. If I have like 10 coins, that the n of s, or the number of total possible outcome of 10 coin, is 2 to the power of